Here's our 11.6 notes, systems of linear and quadratic equations. So we saw systems of equations before, but they were just systems of linear equations. Now what we're going to look at is how do we solve systems of linear and quadratic equations, where we have a system where one of them is linear and one of them is quadratic. So we're going to look at first on a graph what they look like. So if we look at on a graph, when we solve a system, we're going to have one linear, one quadratic, right? Here's our parabola and here's our line. And then our solutions for our system come from the x values of wherever our graphs intersect. So we look here, okay, these x values will be our solutions. The x values of the intersections are solutions. And we know that with systems we can have two solutions. We have two x values. We could have one solution, or we could have no solutions, meaning they never intersect. We have the same types of solutions even when we have just linear systems. There we go. Okay, one solution, the x-coordinate of the vertex would be our solution of the parabola. Okay, so we're going to solve these systems by graphing. Okay, so we're going to graph here. I'm going to graph our parabola and then graph our line, or vice versa. I'm going to go ahead and actually graph my line first. So my line starts at 1, 2, 3, 4, 5, and then goes down to over 1 each time. It's my slope, right? Okay, so there's my line. That's my negative 2x plus 5 graph, and then I'm going to graph my parabola. The y-intercept of my parabola is at 0, 1. It's also my vertex. And then my graph goes over 1 up 2, then over 1 up 6. 1, 2, 3, 4, 5, 6. Over 1 up 2, over 1 up 6. So let me actually adjust my graph and move everything down, because I want us to be able to hopefully see where both of these points of intersection are. So I'm going to go ahead and bump it all the way down to the bottom. And I'm going to go down to over 1. And there's my line. And then graph my parabola, which again is going to start at 0, 1, and then my pattern, right, which is 1, 3, 5, 7, is multiplied by my a value. So instead of going up 1, I'm going to go up 2. Instead of going up 3, I'm going to go up 6, and etc. So I'm going to go over and up 2, then over and up 1, 2, 3, 4, 5, 6. And on the mirrored other half of my parabola, I have the same. So my parabola, we can see it intersects with my graph at 2 spots, with my line at 2 spots at this point and at this point. So then we ask the solutions for this system would be those x coordinates. So the solutions for the system are x equals negative 2 and x equals 1. Because this point is at 1, 3. And this point is at negative 2, what is that, 8? No, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. So those are my two solutions to my system. Let's try another one. Okay. My parabola is going to start at 0, 4, and then it's going to go down. So I'm going to put my grid. If I'm going to say that this is where my parabola is, then I'm going to get, that's 4. So 3, 2, 1, 0. Put my x-axis right here. Okay, so I'm going to go ahead and graph my parabola first. So I start at 0, 4, and then I'm going down at the normal pattern. So down 1, then down 1, 2, 3, then down 1, 2, 3, 4, 5, and mirrored. So again, that's our normal pattern is 1, 3, 5, 7. Okay, there's my parabola. I'm going to graph my line, which starts at 4 and then has a slope of 3. So I'm going to reverse that. Instead of going up 3 over 1, I'm going to go down 1, 2, 3, left 1, down 1, 2, 3, left 1, down 1, 2, 3, left 1. And then we can see, I would encourage you to use a straight edge to draw your line here, but my graphs intersect at 2 different points, 0, 4, and negative 1, 2, 3, 1, 2, 3, 4, 5. So my solutions are my 2 x coordinates there. Solutions are negative 3 and 0. If you have any questions, feel free to reach out to me. You can email me or message me on Remind. My email is alyssa.denhartog@cosd.com. Okay. All right, now we're going to solve not by graphing, but we're going to solve algebraically. So to solve algebraically, we want to know where these two systems are equal, so we are going to set them equal to each other. So x squared minus 6x plus 10 equals 4 minus x. And we want to find the x values where these two systems are equal. Because on a graph, the places where they're equal are the places they intersect. So this is just doing it algebraically now. Okay, so I need to solve this equation. I gotta get my x's on the same side and then get x all by itself or set it equal to 0 or whatever that might look like, okay? So I'm gonna subtract 4 and then add x to get all my terms on one side of my equation here. So on the right side of my equation, I'll have 0 equals, and then on the left side, I'm gonna have x squared minus 5x plus 6. Okay, now this looks just like what we've been solving, right? We're going to go ahead and factor and then set both factors equal to 0 to figure out what x values would make my equation equal to 0. So as I factor this trinomial, I don't have any number in front here. So all I'm going to look for is what will multiply to give me 6 and add to give me negative 5. I think of my factors of 6. They are 6 and 1 and 2 and 3. So I'm going to go ahead and make 2 and 3 because I know that if I multiply negative 2 times negative 3, I will get positive 6. And if I add negative 2 plus negative 3, I will get negative 5. So my two factors are x minus 2 and x minus 3. And then to figure out what my x values are, I'm going to set them each independently equal to 0. Okay, and then solve for x. So I get x equals 2 and x equals 3 by adding 2 and adding 3. Okay, so I have two different solutions, just like we did above. So again, if we were to graph both of these functions, they would intersect at x equals 2 and x equals 3. So let's try another algebraic one. A lot of these you're going to end up factoring. It's a good thing we've been doing that for a while now. So again, we're going to look for where they're equal. So I'm going to set these two equal to each other. negative x squared minus 8x minus 15 equals x plus 3. Okay, now before I moved this side over to the other side, but I see here that I have a negative x squared. It's not very good to have a negative x squared when we're trying to factor, so I'm going to go ahead and move all of these terms to the other side of my equation so that my x squared is positive. So I'm going to add 8x and add 15 and also add my x squared here. Okay, so I'm going to have 0 equals, I'm going to write my x squared term first, then my x term, I'm going to have 9x, and then my constant, I'm going to have 18. Okay, so then here again, we're going to look to factor. What will multiply to give me 18 and add to give me 9? I believe it is 3 and 6. And then we can always check that by multiplying back together, right? X squared plus 6x plus 3x plus 18 will give me what I wanted, right? So these are my factors, x plus 3 and x plus 6. And then to find my solutions, I'm going to set those both independently equal to 0. X plus 3 equals 0, x plus 6 equals 0, and that's going to give me my two solutions. X equals negative 3 and x equals negative 6. Okay, so we're solving systems algebraically, and then on example 4, we're going to solve algebraically and graphically. Now, let's see, the 3x plus 4 and the negative x squared plus 4, that's what we did up here, right? So this graph right here, that's the same graph that we would put down on this example, but we're not going to do it again. Okay, so we already solved for it graphically. When we solved for it graphically on that number 2 example, we got that x equaled negative 3 and x equaled 0. So graphically is number 2 up above. Okay, so what we want to do now is we want to solve it algebraically, and we should get the same x values. So we're going to solve it algebraically like we were doing on those previous examples. Again, I don't want to have a negative x squared, so I'm going to go ahead and move these to the other side of my equation. Okay, that's going to give me a positive x squared. I still just have my 3x here, and then my 4's are going to cancel out. So I'm just going to have x squared plus 3x equals 0. Okay, then again, we're factoring here. So I recognize that I only have 2 terms, so this is not going to factor like the other ones did. Instead, I'm just going to look here for my GCF, my greatest common factor, which is x, and I'm going to factor that out so that I have x and x plus 3 equals 0. And then I'm still going to set each of these factors independently equal to 0. So I have x equals 0, and then I have x plus 3 equals 0. So x equals 0 is already done. I don't have to solve it further. This I need to subtract 3 from both sides. So I get x equals negative 3. So my two x solutions are 0 and negative 3, which are the same that I had when I solved it graphically. So this is how you solve your systems of linear and quadratic equations. Again, if you have any questions, don't hesitate to ask.